So now we are going to discuss properties of the sampling distribution of sample mean. First property है कि mean of the sampling distribution of x1 bar minus x2 bar is denoted by ये है, ये sampling with replacement के लिए भी है और sampling without replacement के लिए भी है. So if you want to calculate mean of this sampling distribution of sample mean, if you want to calculate mean of this sampling distribution of sample mean, it is denoted by mu x1 bar minus x2 bar, and it is always equal to the difference between two population mean. Apart from whether you did your sampling with replacement or without replacement. And if you want to verify it, you can verify it by calculating its left hand side and the right hand side. The left hand side is calculated by summation x1 bar minus x2 bar time f of x1 bar minus x2 bar, and the right hand side is given by summation x1 divided by n1 minus summation x2 divided by n2. And we can verify this quite easily because we are already having the sampling distribution for the difference between two sample means. Now let us see how can we calculate it. To calculate the left hand side, we have to go to the sampling distribution of x1 bar minus x2 bar. We have to utilize this. So we have to add one more column that is, we need to multiply x1 bar minus x2 bar column with its probability f of x1 bar minus x2 bar. For example, if we multiply minus 5 with 1, this is equal to minus 5 and divide by 100. Similarly, minus 4 with 2, this is minus 8 divided by 100. Similarly, we can complete this column. So completed. So if you add it up, it is equal to, so this is equal to 1. So the left hand side, this is equal to 1. Now turn to the right hand side. As we know that x1 is equal to 2, 4, 6, 8 and 10, and x2 is equal to 1, 3, 5, 7 and 9. The sum of all these values is how much? 30, and this is 25. So this is summation x1 and this is summation x2, and n1 is equal to 5 and n2 is also equal to 5. So this is equal to 30 divided by 5 minus 25 divided by 5, or this is equal to 6 minus 5. So this is equal to 1. So the left hand side is exactly equal to the right hand side. So this is the verification of the first property. Turn to the second property. The second property is this is equal to n1 minus n1 divided by n1 minus 1 into sigma 1 square divided by n1 plus n2 minus n2 divided by n2 minus 1 into sigma 2 square divided by n2. This is the case of without replacement. and these are the finite population correction factor. This is the finite population correction factor per population 1, and this is the finite population correction factor per population 2. This is in case of sampling without replacement, and this factor can also be ignored if sample is the percentage of population 1 is less than 5. Similarly, it can also be ignored if sample is the percentage of population is less than 5. ठीक है, तो आपका sample population, how can we calculate sample as the percentage of population? The formula is very simple. You can calculate n divided by n1 into 100. If it is less than 5, and n2 divided by n2 into 100 is also less than 5, you can skip these finite population correction factors. However, if it is equal to or greater than 5, you should include it, right? You can also verify the left hand side and the right hand side by these formulas. These formulas, where sigma 1 square is equal to x1 minus mu1 whole square divided by n1, and sigma 2 square, this is equal to x2 minus mu2 whole square divided by n2. So, by these formulas you can verify the second property. Verify this thing has already calculated. This is equal to 1 whole square. What we need to calculate is this thing. So, let us calculate it in the sampling distribution of sample mean. We need to generate another column for this. The table of the sampling distribution of sample mean is given as, generate the last column, which is x1 bar minus x2 bar whole square into f of x1 minus x2 bar. How can we calculate this column? Multiply this first column by the second last column. If you multiply these two columns, you will get x1 minus x2 bar square time f of x1 bar minus x2 bar. The other way to calculate this column is, you can take square of all these values. For example, if you square minus 5, you get plus 25, and you should multiply it with the probability. So, 25 into 1 is equal to, this is equal to 25 over 100. The alternate way is, multiply the first column with the second last column. For example, minus 5 into minus 5, this is equal to plus 25 divided by 100. So, you get the same value. Okay. Similarly, you can multiply minus 4 with minus 8, 32 plus 32, because minus into minus is equal to plus value. Similarly, if you complete this column, you get, so this is equal to 700 divided by 100, or this is equal to 7. So, this is equal to this is equal to 7. 7 minus 1 is equal to 6. So, the left hand side is equal to 6. Now, turn to the right hand side and calculate it. For the right hand side, we need data x1 and x2. x1 is equal to 2, 4, 6, 8 or 10, and similarly x2 is equal to 1, 3, 5, 7, 9. So, calculate sigma 1 square and sigma 2 square. The formula are given by sigma 1 square is equal to this and sigma 2 square is equal to this. You already know that mu 1 is equal to 6 and mu this is equal to mu 2, which is equal to 5. This is mu 2. We need two more columns, x minus mu 1 and x minus mu 1 square, x1 minus mu 1 and x1 minus mu 1 square. Here also you need two more columns, x2 minus mu 2 and x2 minus mu 2 square. So 2 minus 6 is equal to minus 4. Similarly, minus 2 and 0 and 2 and 4. If you square these values, is equal to 16, 4, 0, 4 and 16. And if you add up, this is equal to 40. This is equal to summation x1 minus mu 1 square. Similarly, 1 minus 5, this is equal to minus 4, minus 2, 0, 1, 2 and 4. And if you square these values, this is equal to 16 and this is equal to 4, 0, 4, 16. This is also equal to 40 and this is equal to summation x2 minus mu 2 square. If you put these summation x1 minus 1 square mu 1 square in this formula, this is equal to 40 divided by 5, this is equal to 8. Similarly, 40 divided by 5, this is also equal to 8. So, sigma 1 square is equal to 8 and also sigma 2 square is also equal to 8. Now, substituting values, now the question is, should we include the finite population correction factor or not? So, let us verify it first. N1 divided by N1 into 100, which is equal to 2 divided by 5 into 100. This is equal to how much? 40. So, this is equal to 40, which is greater than 5. So, in both these cases, the finite population correction factor should be included. Because it is greater than 5. So, the left hand side can be calculated as the right hand side, the right hand side is N1 minus N1 divided by N1 minus 1 into sigma 1 square divided by N1 plus N2 minus N2 divided by N2 minus 1 into sigma 2 square divided by N2. 5 minus 2 divided by 5 minus 1 and this is equal to 8 divided by 2. And similarly, 5 minus 2 divided by 5 minus 1 into 8 divided by 2. This is equal to 3 by 4 into 8 divided by 2, or this is also equal to 3 by 4 into 8 divided by 2. This is equal to 4 and 4 will cancel out with 4. So, this is equal to 3 plus this is equal to 4 and 4 is cancel out with 4. This is equal to 3. So, this is equal to 6. So, this is equal to, this is the right hand side, and you can also see the left hand side is also equal to 6. The left hand side is equal to 6 and also the right hand side is equal to 6. So, it is verified.